All right, guys, talking about the double quiz today. I'm going to do the electric side first, do the gravitation side next. Basically, what I'm going to do through this is run through all the different parts, talk about kind of the ideas of it, and then push you a little bit on the way towards setting up the problem. I'm not actually going to solve any numerical answers. You can do that yourself. So the first thing is we've got this ball hanging from a string inside an electric field, and we have to think about what the forces acting on this object are. Now, the two that if you missed, you should be very ashamed of yourselves. Obviously, we have the force of gravity pulling that object down, and then we have the string pulling the ball in a certain direction. Well, tension always points with the string. So automatically we know that the tension points like this. I had some people point that up, point it to the right, point in all kinds of weird ways. Tension points with the string. If you didn't know that, for shame. We also know that that is a 30-degree angle. And then we know that there's some kind of electric force because this is inside an electric field. It is charged, it's charged positively, so it goes with the electric field, and it's going to feel an electric force in that direction. Now, one other thing we know about this electric force, we know the reason it has to point that way. This is the only direction. This is the only direction that causes equilibrium. If it pointed this way, the ball wouldn't be in equilibrium, so it has to point like that. So that's our starting point. And then we have part B, both of those parts, where we want to calculate the tension and the electric force. Now, the reason we gave this problem was a lot more of a trig and components review than an electric force review. You did not need to understand the electric force to get the next 6 points. That said, you did need to understand components, which apparently none of you do. This is an equilibrium. So for our tension idea, we're going to start with something that we know about. We know about gravity. And since this is in equilibrium, we can automatically say that the y component of tension minus the force of gravity has to equal 0. And so now, can you see that? Yeah. Now all we have to do is just plug in and solve. That's it. Now, the first dumb mistake people made, they didn't put 0. They put mass times 9.8. The ball's not falling down. I don't know why this is such a shock to some of you, but this is not falling down. So for shame if you put there was an acceleration. It's in equilibrium, the net force has to be 0. Now, like I said, we just plug in and solve. We know that this component has to cancel out that component. Well, we need to figure out what that component is. That is the adjacent angle to the 30, which means that side, FTY, is FT times the cosine of 30. Now, we don't know what FT is, but we're looking for it, so that's okay. Minus mg equals 0. If you can't solve that equation for FT, then I have no help for you. So you solve that part for FT, you get that, you're done, fantastic. Now we move on to here. And what a lot of people wanted to do, they wanted to do Coulomb's law, K times Q1 times Q2 over R squared. There's only one charge. Furthermore, we don't know enough information to find it any other way. This is just a component problem again. Again, we can say that this electric force equal and opposite to that one. So the electric force minus Ftx equals 0. Now we've just figured out what the tension force is. So now let's put tension into this. We're trying to find the electric force, so let's leave that alone. Minus Ftx, this right here. This is the opposite of that angle, which means this side is Ft times sine of 30. There we go. Plug in your Ft from earlier, find electric force, solve, be done with it. One thing I will tell you on the retake, I would expect different orientations of the angle. Things will be different here. And so that's that. Moving on. Part C asks about the charge of the ball increasing. And it asks, what is that going to do to this situation? And so when we answer, we need to think about what's going to happen to this situation. So what can we say? Well, if the charge gets bigger, the electric force is going to get bigger. So we're going to get a point for saying that. That force is going to get bigger. We're not going to say that it's going to be different or that it's going to change. We're going to say exactly how. The words change and different are useless on the AP test. Say how it changes, say how it's different. The electric force increases. The force of gravity, nothing happens to it. And so we get a point for saying that. We get a point for saying that charge doesn't matter. Charge doesn't affect that, so that doesn't change. And then we get the final point for saying what actually happens. Is the equilibrium state different? If so, how? We don't say, yes, it's different. Again, that's useless. So if this force gets bigger, that force doesn't change. That's going to pull this whole thing that way. And so there will still be a force of tension. It will be bigger. But most importantly, it will be at a bigger angle. And that's all we say. That's our third point. That's the final, that's the total on there. This problem is out of 3 points, and we just say those things, we get those points. Then finally, part D. And this one was a little bit of a mess. And actually, before I erase that, I'm going to use that free body diagram in my answer. The logic here is that we have this scenario, just like earlier, and then we cut the string. Well, cutting the string is not going to affect the force of gravity. It's not going to affect the electric force. As a matter of fact, all it's going to do is get rid of that. So that's our new free body diagram. So we have to ask ourselves, what motion would be produced by this? Well, I can tell you what's not going to be produced. A motion straight to the right. That'd be like throwing something horizontally and having it move to the right forever and never fall down under the effect of gravity. Well, what's also not going to happen is this. Why would it curve? There's no reason for it to curve. These are both constant forces. Those forces aren't going to change. This is exactly like pushing something in a diagonal line. These combine to produce one net force that is down to the right, which means the motion, first off, is going to be down to the right. The ball, which was hanging on the string, is going to accelerate down to the right, but it's going to accelerate very specifically down to the right. It's not going to go at any old angle. It's going to go at exactly the angle of the string. It has to go at the angle of the string because that's where the tension was, that was the balancing point. It can't go any other way. And so we actually got 2 out of the 3 points for just doing that. But then we have to describe the motion. We have to ask ourselves, what happens to an object when there is an unbalanced force acting on it? We don't say it moves, we say it accelerates. It's going to speed up. This object is going to accelerate down and to the right. It's not just going to move down and to the right. It's going to accelerate down and to the right. It's going to speed up. So we say that, we get all the points. Now let's move over to the other side. Now, this side, only parts A, B, and C were graded. Meaning those are the only 3 parts that actually affected your grade. On the retake, though, you'll need to be good at all of it. So let's walk through all of it. The first question is one of the easiest questions that we will ever ask you on a quiz. It says, write down an expression that relates the force of gravity that talks about the force of gravity between Saturn and one of its moons. So automatically, you should know that you're thinking about this big formula off the formula chart. However, I didn't ask you to copy the formula off for the force of gravity off the formula chart. I asked you to talk about the mass of Saturn and something else. They tell us that the mass of Saturn is that, so we plug that in and we're done. That's part A. Very, very easy. Part B, believe it or not, is also very easy. I ask you to relate that expression to circular motion. Well, that means we're going to use that expression in our answer. So let's start off with that. This big old force. It's going to equal something. And so now we think about circular motion and centripetal force and how that works. The force of gravity here is actually going to act as the centripetal force. So this is equal to mv squared over r. Because this force is pretending to be a centripetal force. It's acting like a centripetal force. Putting that down, automatic 2 out of 2, done. So that's that. Then part C wants us to bring the period into the game. And the only way to do that is to think about that velocity. So we know that velocity is equal to 2 pi times the radius over the period. Well, before I copy this down over here and start plugging stuff in, I notice that that goes away. You didn't have to cancel them to get full points in part B. You just had to put that down. And so now in part C, we're going to combine all of this stuff and rearrange it and solve it for the period, just like we're supposed to. So we plug that into here. It's also worth noting we can cancel that out as well. We plug that into here, and we end up with this equation. G times the mass of Saturn over the radius is equal to, this was squared, so we square all of this, and we get 4 pi squared r squared over t squared. Getting to this stage got you 2 out of the 3 points. However, you needed to rearrange and make an equation for period. And so let's do some rearranging. Let's get all the period over here and everything else over there. We end up with t squared equals, what do we get? 4 pi squared over g times the mass of Saturn, all times r cubed, excuse me. And there we go. That is 3 out of 3. Now, ideally, in my perfect world, you actually would have square rooted both sides and solved exactly for t, but that's honestly kind of challenging. With the algebra is already pretty ugly, getting to here is okay for me because part D? Yes, part D asks you to look at this equation that you just made and think, what do I put on my x and my y axis so that my slope has the mass of Saturn in it? Well, we look at our equation. It's already kind of looking like y equals mx. This thing is going to go on our y-axis, all of t squared. This thing is going to go on our x-axis, which means all of this is left for our slope. Doing something like that got you 4 points. Now, I do want to say that if you did something different, if you maybe did t squared over here, and then maybe you did 4 pi squared times r cubed divided by g as your x-axis, in other words, you only had the mass in your slope, that's cool too. As long as you have this on your y-axis and this on your x-axis and it makes sense, you're good. That's going to be your 2 out of 2 points right there. And then you move on to part E. You calculate your data table for what you're supposed to calculate. You actually didn't get any points for that. And then part F, assuming that you have the right x and y axis, and assuming that you calculate your data correctly, you go through and you plot your points, you draw your line of best fit, do whatever you need to do. And then part G asks you to calculate the slope and use that slope to find the mass of Saturn. Well, to do that, you first need a line of best fit. Then you need to use points from that line of best fit to calculate the slope. And then, assuming you did it that way, you're going to say slope equals 4 pi squared over g times the mass of Saturn. Plug in whatever you got for your slope, do some solving, do some rearranging, and solve for the mass of Saturn. Now, it is worth pointing out that this quiz was a hard quiz. This backside was pretty tough. So that's why we only graded you A, B, and C. Those of you who boldly forged ahead and you tried to do something and you made a graph and you tried to use that graph, you should be proud of yourself. This is a Physics C problem. It's a tough one. Getting to the graph is a very good thing here. Don't give up on quizzes in the future. That said, study this quiz like a lot. You need to know how to do this. Components are a huge part of the AP test, and you'll need to be able to do them in your sleep. So know how to do that quiz. It's going to come up again. That's that. My kids and Ariz's kids, both of you guys have to do corrections on this, meaning free response style. Solve the correct answer and say why you got it wrong. You must explain why you got it wrong, because realize I'm kind of doing it for you. So say why you got it wrong, and then come up and show it to me or Ariz and say, here's my corrections, I'm ready to retake, and then once you do that, you retake the quiz. And that's that. See you guys.